Hello, in this lesson, we're going to be looking at sum and difference identities. Sum and difference identities come from our trig identities. If you have the sine of the sum of two angles, it's sine, cosine, cosine, sine. Sine of the first angle times cosine of the second angle plus cosine of the first angle times sine of the second angle. If you're adding, we put a plus between them. If you're subtracting, we put a minus between them. The cosine of a sum or difference is cosine, cosine, sine, sine. And it's kind of backwards. If you're doing the cosine of a sum, we subtract. If we're doing the cosine of a difference, we add. The tangent of a sum or difference is the tangent of A plus the tangent of B over 1 minus the tangent of A times the tangent of B. And then it's just backwards from minus. You minus, then you add. So if I want to find the sum or the exact value of the sine of 75 degrees, what I'm going to do is I'm going to think of two angles on my unit circle that will give me 75 degrees. So I would think this is the same as the sine of 45 plus 30. So what that is, that's the sine of A plus B, which we know is the sine of A times the cosine of B plus the cosine of A times the sine of B. On this problem, it'll be the sine of 45 times the cosine of 30 plus the cosine of 45 times the sine of 30. Well, the sine of 45 we know is the square root of 2 over 2. The cosine of 30 degrees is the square root of 3 over 2. Plus the cosine of 45 is the square root of 2 over 2. And the sine of 30 degrees is 1/2. So we can simplify that a tad. So that we're going to get the square root of 6 over 4 plus the square root of 2 over 4, which a lot of times we'll write that as the square root of 6 plus the square root of 2 all over 4, just a common denominator. Now, how am I going to do negative 75 degrees? I guess I could do negative 45 and negative 30, but I'm going to think of it a different way. How about if I do this? I'm going to do the cosine, let me change colors here, of 120, because I know that's in my unit circle, minus 45. Still have the 45 in there. So if I take 120 minus 45, actually that's backwards. That would give me 75. I want negative 75, so I'm going to rewrite that as 45 minus 120. So that's the same thing as the cosine of A minus B, which is cosine A, cosine B, plus sine A, sine B. Well, I'm going to find the cosine of 45 times the cosine of 120. My 120 looks kind of sick there. I'm going to rewrite that. Plus the sine of 45 times the sine of 120. Well, the cosine of 45 is the square root of 2 over 2. The cosine of 120 degrees is negative 1/2. Plus the sine of 45 is the square root of 2 over 2. The sine of 120 is square root of 3 over 2. Got to think about that for a second. Okay, so then we get negative square root of 2 over 4 plus the square root of 6 over 4. Write that with a common denominator. You can write negative square root of 2 plus the square root of 6 all over 4. Or you could say the square root of 6 minus the square root of 2 all over 4. Either one of these three ways is an acceptable way to write that problem, that solution.